Welcome. Today we are going to learn how to actually solve a matrix equation. Last time we learned how to find or calculate the inverse of a matrix, if it has one. But as a quick review, we have a 2 by 2 matrix. The determinant is equal to AD minus BC, AD minus BC. And if the determinant doesn't equal 0, then it has an inverse, which is 1 over the determinant times, as we take this matrix, swap the A and the D, and change the sign on the B and the C, that gives us our inverse. So let's do an example. Here's one in our IXL lesson. We have some unknown matrix Y times this 2 by 2 matrix, 1, -5, 1, -7, and it equals this 2 by 2 matrix, 4, -5, 1, 5. So we want to know what Y is. Now, order that we multiply matrices matter. So we got to be very careful as we go through this. First thing I'm going to do is I'm going to find the inverse of this 2 by 2 matrix because I want to remove it so I can get Y by itself, just like a normal equation. And to get rid of this 2 by 2 matrix, I need to multiply it by its inverse. So I'm going to find the inverse of 1, -5, 1, -7. So the first thing I'm going to do is find its determinant. The determinant is equal to A times D, 1 times -7, minus B times C, -5 times 1. And that's going to be a -7. Negative times a negative is +5, or we get a -2. So our determinant is -2. Now I'm going to, since it's not 0, I know it has an inverse. So now I'm going to find its inverse. First thing I'm going to do is I'm going to swap the place of those two. So I'm going to put the -7, that was this bottom left one, or right one I mean, up to the top right, left. And then I'm going to put the 1 there, so those two swapped. I'm going to change the sign of those two. So that's going to become a +5. That's going to become a -1. And now I'm going to take this 2 by 2 matrix and I'm going to multiply by 1 over the determinant. 1 over -2. So I'm multiplying by -1/2. So that means the inverse of this matrix is the matrix 7/2, because that's the -7 times the -1/2, makes it positive. -5/2, 1/2, because that's the -1/2 times -1. -1/2 times +1 is -1/2. So my inverse matrix is this 2 by 2 matrix that has these 4 fractions. Now, what I'm going to do, and I'm going to write this out, you wouldn't have to always do this, but if I take Y, that unknown matrix that is being multiplied by 1, -5, 1, -7, and I multiply by its inverse matrix, 7/2, -5/2, 1/2, and -1/2. Now what I want you to notice is I did not separate the Y with its original matrix. I didn't put the inverse in between. I put the inverse behind. That means I need to put the inverse behind this one. So that's going to equal 4, -5, 1, 5 times that same inverse matrix, which is the 7/2, the -5/2, the 1/2, and the -1/2. Now, I normally wouldn't take time to do this, but I'm going to do it this time so you can see that this ends up being what's called the identity matrix. So Y times, so here we go. Remember, it's going to be a row times a column. So 1 times 7/2 is 7/2, plus -5 times 1/2 is going to be a -5/2. And if I add those two together, 7/2 minus 5/2 is 2/2. That becomes 1. That was the first row times the first column. Now I'm going to do the first row times the second column. So 1 times negative 5 halves, that's negative 5 halves, plus negative 5 times a negative 5 halves makes it a positive 5 halves. So I got negative 5 halves plus 5 halves, that's 0. Now I'm going to do the bottom row times the first column. 1 times 7 halves is 7 halves. Negative 7 times 1 half is going to be negative 7 halves. If I add those two together, I get 0. You can almost see this matrix that I'm setting up here, right? Now I'm going to do the last one here. Last row times the last column. 1 times a negative 5 halves would be a negative 5 halves. Negative 7 times a negative 1 half will be a positive 7 halves that I'm adding. Add those two together, we get 2 halves or 1. Look at that. That's the identity matrix. Equals. Now I'm going to do the same thing here. I'm going to multiply these two. Now be warned, this will not be the identity matrix. But I'm going to still do the same thing. First row times first column. 4 times 7 halves is going to end up being 14. Negative 5 times a 1 half is going to be a negative 5 halves. Again, what I'm going to do is should have probably left this as a fraction, left it as 28 over 2, because 28 minus 5 is 28. I can do 28 minus 5. It's 23 halves. So this first term becomes 23 halves. Now I'm going to do the first row times the second column. 4 times negative 5 halves is going to be a negative 20 halves. Negative 5 times negative 1 half is going to be a positive 5 halves. So when I add, I get a negative 15 halves. Negative 15 halves. Now I got to do that second row times the first column. So 1 times 7 halves is 7 halves. 5 times 1 half is going to be 5 halves. I'm going to add those together. 7 halves plus 5 halves is 12 halves, which becomes 6. Then the last row times the last column. 1 times negative 5 halves is going to be negative 5 halves. 5 times a negative 1 half is going to be a minus 5 halves more. That's going to be a negative 10 halves, or negative 5. Now, this identity matrix times y gives us just old y. So y is this. This is my matrix y that I would have multiplied by this to get that. Let's type it in and see how good I did. I got a 2 by 2 matrix. My first one is a fraction of 23 halves. So I type in 23 halves. The second one was also a fraction of negative 15 halves. 15 halves, that is negative. The bottom one ends up just being 6. And the fourth one ends up being negative 5. And we have our y value. Booyah, we did really good. Now, as you work through these, as soon as you get to a 3 by 3 matrix, you can stop. But I want you to get up to a 3 by 3. Now, I know these are a lot of work, but I'm only going to sign the 1. And again, you should get faster and faster of it, because again, this part of it you really don't need to do, because when we multiply, we know we get that identity matrix. So let's do one more. So you have one more example of us doing this. Again, I'm going to keep these notes right here at the top so you can see the matrix. So I have, first of all, this, it has Q times X equals R. I know the Q and I know the R, I'm looking for the X. So I need the inverse of the Q. So I'm going to write this Q down. Q is negative 2, 6, 0, 2. Again, I'm looking over here at my Excel, so hopefully you're looking over here. I'm going to make sure it has a determinant, so it has an inverse, because I noticed that it actually gives you the option of saying undefined, so that might happen. The determinant is A times D, negative 2 times 2, minus B times C, 6 times 0. Well, that just equals negative 4, because that's 0, that's negative 4. So we do have a determinant. So now I'm going to find my inverse. I'm going to do negative 1 over 4, that's this reciprocal, times, now I'm going to swap the place of those two. So that positive 2 will go up in the top left, the negative 2 will go down to the bottom right, and I'm going to change the sign. So the 6 changes to negative, the 0 stays 0, and now I'm going to distribute in, and I find out that my inverse matrix is negative 1/2, positive 3/2, 0, and 1/2. Again, that times that was this one, that times that is that, this times 0 is that, and that times that is that. Now I have my inverse. Again, I want you to be very, very careful. Not that you'd have to write this down. If you'll notice, I'm looking for my x value. My x, I know Q. Don't put your inverse matrix in between. We're going to put it in front. So I'm going to go negative 1/2, 3/2, 0, 1/2, times my Q matrix, which is negative 2, 6, 0, 2, equals, now I put my inverse matrix in front of Q, so I'm going to put my inverse times x, don't forget there was an x there, that's our inverse, that's Q, that's x, equals, now since I put my inverse in front of Q, I'm going to put my inverse in front of R, so I'm going to do the negative 1/2, the 3/2, the 0, the 1/2, and I'm going to times that by my R. So I look back over here on my Excel and I find out my R is 3, negative 2, 5, negative 1. Again, these two, in other words, cross cancel. They just cancel out and we get x equals. So we're going to find our value of our inverse matrix. So here we go. I'm going to do this again kind of a couple ways. I'm going to do, and not couple ways, but I'm going to do that first row times the first column. So negative 1/2 times 3 is negative 3/2, plus 3/2 times 5 is going to be 15/2, and 15 minus 3 is 12/2, which gives us 6. So that first term is 6. Now I'm going to do the first row times the second column. Negative 1/2 times negative 2 will give me a 1. 3/2 times negative 1 is going to give me a minus 3/2. And again, I probably should have just left this as negative or positive 2/2. 2/2, and 2/2 minus 3/2 is negative 1/2. So I got my second term. Now I'm going to move down to my second row, first column. 0 times 3 is 0. So I have 0 plus 1/2 times 5 is 5/2. So this term here is 5/2. Now I'm going to do 0 times negative 2 is 0, plus 1/2 times negative 1/2 is negative 1/2. So I get negative 1/2. And there is the solution to my expression. So I come over here, hit the 2 by 2. My first number was a solid whole number 6. The second one was a fraction of negative 1/2. The third one was also a fraction of 5/2. 5/2. And the last one was a solution of negative 1/2. Negative 1/2. Now, I would always make sure that I double check, because you don't want to mess one up and go back. Not that Excel's being mean or anything, but if, yep, looks like everything is correct. So I hit submit, and after 2 problems, I'm already up to 50. So if you have any questions, please email me. And again, you only have the one assignment, and you can stop when you get to your first 3 by 3.